Hello there, Mr. Sutton here with the IM3 7-3 Extra Practice number 3 solutions on right triangle trigonometry. To find this missing angle in this right triangle, since we already have two sides of the triangle, we can use SOHCAHTOA to figure out this angle. So looking at the sides they gave us, we have the side that's across from the angle, so that's actually the opposite side, and also this other side that's touching the angle but isn't the hypotenuse. So this is the adjacent side then. So if we have opposite and adjacent, we're using the TOA part of SOHCAHTOA. So that's tangent equals opposite over adjacent. So then we can write down tan of whatever the angle is. So we'll call this x. And then opposite, that's going to be this 38 side that's across from it. So we have 38 over the adjacent side, which again was this 48 side. Now to find x, we have to take the inverse tan of both sides of this. So we're going to write x equals tan inverse of 38 over 48. And at this point, it's time to use the calculator. So on the calculator, I'm going to do second tan. And now I'm going to do 38 divided by 48 in there and press enter. And that gives us, and this is an angle, so this is going to be in degrees, 38.4 degrees. On this problem, we're trying to find this missing side of a right triangle. Since we only have one side here, we can use either SOHCAHTOA or we can actually use a special right triangle here because we do have a special angle, 45 degrees. This is a 45, 45, 90 triangle. So one way you might do this is you can think of this 39 as s radical 2 and then divide by radical 2 and you would actually end up with these other two sides. So that's one way to do it. Another way to do it, I'm going to show you the SOHCAHTOA approach. So looking at what we've got here, we're looking for the hypotenuse, and we have, this would be the adjacent side because it's the non-hypotenuse leg of the angle that they gave us. So we have adjacent hypotenuse, that would be the ka part of SOHCAHTOA. So we can write cosine equals adjacent over hypotenuse. So cosine of 45 degrees equals our adjacent side, which was x we said, over that hypotenuse they gave us of 39. And now to solve for x, we can multiply both sides by 39. So 39 times cosine of 45. And this is a task at this point for the calculator. So on our calculator, we have 39 times cosine 45 degrees. And press enter. And that'll give us 27.6. Now again, we said you could take your hypotenuse, which was 39. And if you divide that by radical 2, you should end up with the same thing using special right triangles. So 39 divided by square root of 2. Let's see what that comes out to. Yep, same thing. So either approach works. Either way, your answer is 27.6. For this one, we're trying to find a missing side of a right triangle. Now, we only have one other side, and this is not a special right triangle. This is not 30, 45, or 60 degrees they gave us. So SOHCAHTOA is our only option on this one. So let's see what sides we have. Based off of this angle, they gave us the opposite side that's across from the angle, and this is the non-hypotenuse leg of our angle, so this is the adjacent side. Opposite and adjacent, that's TOA, so this is tan equals opposite over adjacent. So we can write tan of our angle, tan of 52, equals that opposite side of 17, that's the side across from the angle again, and divide that by the adjacent side, so that's this x side that's not the hypotenuse, but still touching the angle. To solve for x, we can multiply by x and then divide by tan of 52. So basically interchange these. So 17 over tan of 52 is what we end up doing on the calculator. Let's do that now. So here we go. 17 divided by, we said tan, there's the tan button of 52. Press enter. That's about 13.3. For this one, we're trying to find out this missing angle in a right triangle. Now, since we have two sides, we're able to use SOHCAHTOA on this one. We have the hypotenuse, that 53, across from the right angle, and the 17 across from the angle, that's going to be our opposite side. So opposite and hypotenuse, that's going to be the SO part of SOHCAHTOA. So we have sine equals opposite over hypotenuse. So we can write sine of our mystery angle, which I'll call x for our purposes here, equals our opposite side, that was the 17 across from the angle, divided by our hypotenuse, we said that was 53. And to find x, I actually have to take the inverse sign of this equation. So we have x equals sine inverse of 17 over 53, which I will now do on the calculator. So we do second sine and then 17 divided by 53, 17 divided by 53 gives us about 18.7, and that's in units of degrees because this was an angle. For this problem, we're trying to find this missing side of a right triangle. Since we only have one side to work with, and we don't have an angle that's 30, 45, or 60, it's not a special right triangle, we'll use SOHCAHTOA instead. So the sides that we have here, we don't have the hypotenuse. We do have the opposite side across from the angle, and the adjacent side, that's the non-hypotenuse leg of the angle. So with opposite and adjacent, we have to use the TOA part of SOHCAHTOA. So we have tan equals opposite over adjacent. So then we can write tan of our angle, tan of 67, equals the opposite side across from the angle. We have the x divided by the adjacent touching side, that was 20. And then to get x, we just multiply by 20. So we have 20 times tan of 67. Let's see what the calculator says about that. So 20, and then we'll just do tan, it knows we're multiplying, times 67. Close the parentheses if you want, press enter, and that is about 47.1. On this one, we're trying to find the hypotenuse of this right triangle, but since we don't have any special angles here like 30, 45, or 60, and since we only have one side to work with, it's SOHCAHTOA or nothing on this one. So based off our angle, in addition to the hypotenuse, we have the side across from the angle, the opposite side. So with opposite and hypotenuse, we have to use the SO part of SOHCAHTOA. That's going to be sine equals opposite over hypotenuse. So we have the sine of our angle, 23, equals the opposite side across from the angle, that's 38, divided by the hypotenuse, which is x in this case. And to get x, we have to multiply x to the other side and then divide by sine of 23. So we have x equals 38 over sine of 23, which we now need the calculator for. So on the calculator, we've got 38 divided by, here's the sine button. We'll plug 23 into that, press enter, and that comes out to 97.3 if we round off to the nearest tenth. On this problem, I'm trying to find this missing side of a right triangle. Since I only have one other side to work with, and it's not a special right triangle with a 30, 45, or 60 degree angle, I'm going to go with SOHCAHTOA for this. So because I have the hypotenuse and this non-hypotenuse side that's touching the angle, this is the adjacent side over here, I'm going to use CA, that part of SOHCAHTOA. So we've got cosine equaling adjacent over hypotenuse. So we can say cosine of our angle, 71 degrees, equals that adjacent side, the non-hypotenuse leg of the angle, 33, divided by our hypotenuse of x. And to get x, we have to multiply by x and divide by cosine of 71. So basically switch the x and the cosine 71. And the calculator is all that's going to help us out at this point. So on the calculator, I've got 33 divided by, let's see, here's my cosine button, 71, enter. And that comes out to 101.4. There we are. On this problem, trying to find this missing side, since we have a right triangle and only one side and a non-special angle, it's not 45, 30, or 60, we're using SOHCAHTOA. So we've got the hypotenuse, and we're looking for the side that's across from the angle, so that's the opposite side. Opposite and hypotenuse means we're using the SO part of SOHCAHTOA. So we've got sine equals opposite over hypotenuse. So that's sine equals 40, or sine of 43 degrees equals our opposite side we said was the x over here that we're looking for, and we're dividing by that hypotenuse of 26. To get x, I'm going to multiply both sides by 26. So that's 26 times the sine of 43. And let me use my calculator to get the rest of this. So here we go, 26 times the sine of 43. Press enter, and that comes out to about 17.7. To find the missing angle on this problem, since it's a right triangle with two sides given, I can use SOHCAHTOA. So the sides that they gave me, the hypotenuse here across from the right angle, that one's easy to pick out. We also have the non-hypotenuse leg of the angle that's touching the angle there. So that's our adjacent side. Adjacent hypotenuse, that's going to be the CA part of SOHCAHTOA. So cosine equals adjacent over hypotenuse. That's our basic setup formula. So we can write cosine of, I don't know, I'll just give it a name, x, equals our adjacent side, we said that was 51, over the hypotenuse of 57. And now I need to do cosine inverse of 51 over 57 to actually get x, because cosine inverse undoes cosine. Let's use the calculator for this. On the calculator then, we're doing second cosine, and then 51 divided by 57. Enter to get, this is in degrees now, 26.5 degrees.